Hi there, we're having a look at working out volumes of different types of shapes. Have you ever wondered how much sugar there is in a sugar cube? Just going to work out the volume of this shape. Now I'm just tracing around the outside, and what we need to know is the area of one face. To calculate that out, we actually need to we're gonna work out the area of the end, and we need to know the lengths of the sides. Now the lengths of the sides for this sugar cube, they're 2 centimeters each. So so we'll do the first side. So area is equal to length times breadth, and that, because all sides are the same length, it's 2 times 2. So that fairly obviously is 4 centimeters. Now it's centimeters times centimeters, so it's a two-dimensional shape. It's centimeters squared. When we're looking at volume, it's length times breadth times depth, and so we've already worked out the length times breadth is 4, and the depth, because all sides, all lengths are the same size, 2. So that's 8 centimeters, and now it's centimeters down one side times centimeters along the other side times centimeters again. So it's 3 lots. It's three-dimensional. It's centimeters cubed. So that's the answer to that one. We're going to have a shot now at working out the area of this toilet cistern. Now, toilet cistern is essentially the tank on the top of the toilet, which holds the water. So what we need to do, it's the same principle. We're going to work out the area of one face, and then we're going to multiply it by the depth. And so we need to acknowledge that it's heading back. So just draw that in and down the side. So going down the side there, it's 40 centimeters. Across the base, it's 60 centimeters, and the depth is 5 centimeters. So to calculate that out, we'll work out the area of the front face first. There's no reason why it has to be the front face first. It could be any side first, and then multiply it by the depth or the length that we have there. So the area is equal to length times breadth, and so it's just the same as you'd work out for any square. So it's 60 times 40, and 6 fours are 24, and 2 zeros on the end. And same principle as far as sort of the units go. It's centimeters times centimeters, so it's centimeters squared. Now, if we're having a look at the volume, then it's length times breadth times depth, and that is, we've already worked out 2400 for the length times breadth, times the depth is 5. Now you might not know how to do that just off the top of your head, so let's just do it over here. It's a pretty quick calculation to do if we set it up like this. So 0 times 5 is 0, 0 times 5 is 0, 4 5s are 20, and 2 5s are 10, plus 2 is 12. So the volume is 12,000 centimeters. And what's this going to have to be? Is it centimeters? Is it centimeters squared, or is it centimeters cubed? We're going in 3 different directions. It's cubed. Have you ever wondered how much Red Bull they have in these cans on the back of the car if you were to fill it up with Red Bull? It's a pretty scary proposition. What we're going to do is we're going to work out the volume of this can. Now, to do that, it's the same principle. You need to work out the area of the end of the can, and if you have a look at that, it's a circle. So to work out the area of a circle, you need to know the radius of the can. Now, I actually have measured across the base of one of these cans, and the diameter of the can is 1.5 meters. So now I'm going to work out the area though, you use the formula pi r squared. So that is pi times the radius is half of 1.5, so it's 0.75 squared. Now, if you thump that through your calculator, you'll come up with an answer which is 1.77, and the units we're looking at are meters, and again, it's the area of that whole circle, so it's squared. Now, we're actually interested in volume here. So volume is going to be equal to the area of that circle multiplied by the length of the can. So the area of the circle is 1.77, and the length here, we need to measure that, and we worked out the length of that to be 2 meters. So multiply those two together and you end up with about 3.5 meters, and this is three-dimensional, meters cubed. So now we want to actually convert 3.5 meters cubed to liters. So the easiest way to do that, if you don't know, is just to grab a program like this one that I've found here online, and we're going to change 3.5 liters, cubic meters, to 3,500 liters. Now you imagine drinking 3,500 liters of Red Bull. It's a pretty scary proposition, isn't it? 3,500 liters. Yikes.